ठीक है. Let f is a function from closed interval ab to r be such that the first thing, f must be continuous. That is, f is continuous on closed interval ab. The second thing, f is differentiable on open interval ab. Okay. And third thing is, if f of e is same as f of b, then there exists a point C which belongs to AB such that f dash of C is 0. F dash of C is 0. Read the statement carefully and try to see मतलब proof क्या करना चाहता हूँ. What do I want to say here? Derivative at C is 0. If f of A and f of B are same. Yes. Graphically, let us see what are the conditions given. You should have a continuous function, you should have a differential function, and f of A and f of B is same. A simple example, I can take this one. Say this is point A, this is point B, and the value whatever you are having at f of A, the same thing is here f of B, correct? So either you can have something like this is a function, or something like zigzag, or something like this. Correct? What do you see here? Look at this, whether the function satisfy all the three conditions. Whether the function satisfy all the three conditions. The first condition is function should be continuous. It is quite clear from here, that is, it is continuous. It should be differentiable on E and B. There is no edge in between E and B. There is no edge shape or V shape here, so it is differentiable. And third thing is f of A is same as f of B. What do you see here? F of E, this is the value. F of B, the same thing, this is the value. So what is your conclusion? That is, there exists a point C such that f dash of C is 0. But what do you know about f dash of C? F dash of C is what? It is slope of tangent. That means there should be a point C at which slope of tangent at that point must be 0. Slope is 0, that means what? That line should be, that tangent should be parallel to x-axis. Do you see some point? And do you see? Yeah, this one. Look at this point. If I draw a tangent here, क्या है? It is quite different. Yes. If you draw this tangent, do you see this point C? This is lying between A and B, and you are having this thing. Perfect. Yes. Now next question is whether this C is unique. Whether can I have only one C in that? No, definitely not. You draw another diagram like this. Look at this diagram. So most of the people used to do the mistake. They used to say there exists unique C. That is wrong. Look at this. Suppose I am having something like this. Correct? Again, see, all the conditions are satisfied. It is continuous in this interval A and B. It is differentiable in this interval A and B. And what else? What else? Do you see? This tangent, this tangent, this tangent, this one, and this one. Each of them is having derivative 0. So in particular, this is the definition of Rolle's theorem. And what does it say? If your function is continuous, it is differentiable, and f of a is same as f of b, then what? Then there should exist a point C such that this should happen. Correct? And here we are going to use the extreme value theorem. I hope you remember what is extreme value theorem. Of continuity chapter, that is unit 2. What is the extreme value theorem? In particular अगर बोले तो a continuous function on closed and bounded interval is bounded and attains its LUB. Just right here, recall. What is that? A continuous function f on a closed and bounded interval, on a closed and bounded interval is bounded. That function should be bounded, and it attains its bound. That means it should have LUB and GLB. I think हम लोगों ने LUB के लिए प्रूव किया था, and I told you to do the GLB. Attains its bound की जगह you can say its LUB and GLB. This is extreme value theorem. Okay. So what do you see the function here? It is again closed interval a to b, and whether it is continuous? Yes, I am already given function is continuous in this. So can I use the extreme value theorem? That means it will have maximum and minimum. Correct, yes. So let us start the proof. Let us try to understand it very properly. By extreme value theorem, there will exist, you can say there exist say 2 points x1 and x2 which belongs to AB, such that एक तो minimum रहेगा एक तो maximum रहेगा, such that you can say f of x1 that is less than equal to f of x and that is less than equal to f of x2. Do you understand why I'm writing this? Since your function is continuous on closed interval a to b, it will have its maximum and minimum, that is GLB and LUB. So I am saying that there are point x1 and x2 such that f of x1 and f of x2 something, f of x1 is less than f of x and that is less than f of x2. Correct? What else then? If you are having this, what else? For all x belongs to AB. Okay. Now there are two conditions you should see. If your f of x1 and f of x2 are same, then result is trivial. Do you know why? If you remember last proof जो मैंने किया था तुम लोग के लिए, this one, उसमें भी ऐसा ही कुछ condition था. Yeah, you can see it here. F of x that is less than f of c, and f of c is between f of c plus h and c minus h. By using this technique, if you are having this thing, but if you are having your f of x1 and f of x2 are same, if f of x1 is same as f of x2. What do you mean by that? That means your maximum and minimum are same. So what can you say then? That function will be constant, na? Implies f is constant. जब maximum और minimum same है तो what can you say? F must be constant function. Correct? If it is constant, then what is derivative of that? And actually it is for any c. I don't have to choose any particular. So for all c belongs to AB, what I will be having, f dash of c is 0. Hence proof done. Correct? So two things I am going to take. The first thing, yes. Can you hear me? Yeah. So two things I have to check. I have to take two cases. The first case is if my f of x1 is same as f of x2, then my function should be constant. Why? Why that is so? Because you are already telling this f of x1 is minimum value, that is you can say greatest lower bound. This is GLB and this is LUB. If your LUB and GLB are same, that function must be a constant function. Correct? So if they are equal, then function must be constant, then derivative 0, then result is true. The second thing I have to take, if f of x1 is not equal to f of x2, if f of x1 is not equal to f of x2, then what? That means if minimum and maximum are not same, then can I say this? Then at least one of x1 x2 is different from A and B, is different from A and B. Can I say this? Think about this. Suppose your x1 x2 is same as A and B, then what will happen? Suppose अगर x1 x2 A and B हुआ तो by the third condition you are getting f of A is same as f of B ना? That means minimum is same as maximum. Correct? So दोनों में से कोई एक तो different होना चाहिए A and B से. I will write it. If say x1 x2, suppose they are same, x1 x2, either x1 is same as A, x2 is B, or x1 is same as B, x2 is A, then what will happen? As by third condition I have f of A is same as f of B, then my function must be constant. Function is constant. That case I have already taken. But यहाँ पे अगर मैं not equal बोल रहा हूँ, if I am saying f of x1 is not equal to f of x2, then at least one of x1 x2 is different from A and B. Do you agree? I have already told you, if they are not different, then if they are not different, they are same as A and B, then by third condition f of A is same as f of B, you will be having your function as constant. Or you will be having f constant भी नहीं बोला तभी भी you will be having f of A equal to f of B, which is giving me a contradiction to my assumption. What I am taking f of x1 is not equal to f of x2, but I am getting f of A equal to f of B. So this is a contradiction. You can also say like this. This is a contradiction to our assumption. Correct? So suppose दोनों में से एक तो कोई एक बंदा क्या रहेगा? A रहेगा and other thing will be B. So suppose, let us take a point. Suppose x2 is different. Suppose x2 is different from A and B. Suppose there is an x2 which is different from A and B. That means what? X2 will lie in between A and B. correct? And let us say that x2 as c. Let your c is that x2. Okay, then what next? Try to observe x2 क्या है, that will give me maximum value. So can I choose a delta? Can I take delta? Let delta equal to minimum of c minus a and b minus c. Why I am taking this interval? You'll see here. कहाँ पे है graph? Let us draw a graph here. This is A, this is B, and suppose you are having something like this. Suppose your point C is here. So what I have to take, actually I have to take a delta which is completely lying inside the interval. So I have to take minimum of this length and this length, correct? If I want to have a neighborhood, I will try to keep that neighborhood inside the interval only. That was the first thing I need to make sure, correct? So what I have to take? I have to take my delta as minimum of c minus a and b minus c. So that is what I am taking here. Choose delta equal to minimum of c minus a and b minus c. Do you see that this thing is contained in AB? Not this thing actually, that interval, because I am taking minimum. So I can say this thing, that is c minus delta and c plus delta, that is contained in AB. Do you agree? Why? Because what is your delta? Delta is minimum of c minus a and b minus c, करेक्ट? सो मिनिमम क्या रहेगा? ये हो सकता है, आइदर ये हो सकता है या ये हो सकता है. टेक टू केसेस एंड सी. डेल्टा अगर सी माइनस से लिया तो आई विल बी हैविंग ई माइनस समथिंग, ए और समथिंग आएगा. एंड इफ आई एम टेकिंग बी माइनस, सो आई एम गेटिंग समथिंग कॉमा बी. सो बोथ द थिंग आर completely lying in between a and b, in the interval a and b. What do you observe from here? What do you mean from this? You are having f of x is less than equal to f of x2 in this delta neighborhood. What can you say then? Yes? Can I say that? And one more thing. What was my x2? What was my x2? f of x2 क्या था? Highest point ना? See, what was my f of x2? This is least upon one, or you can say maximum. और ये क्या है? Minimum. Since interval में है तो I can talk about maximum. But what is my f of x2? And actually it is global maximum. कोई भी point ले लो, f of x का सबसे बड़ा वही है. So you can say since c equal to x2 is a global maxima, global maximum, what I have f of x is less than f of c for all x belongs to this interval c minus delta and c plus delta. What do you mean by this? Can I conclude something? If your function is satisfying this condition in this delta neighborhood, उसका मतलब क्या होता है? This is local minima, correct? Local maxima. I hope you remember local maxima and local minima का definition. Local maxima of f. What do you mean by local maxima of f? By previous theorem I have proved already. Do you remember? I have proved something. Look at this theorem. I just wanted to use this. If c is local extremum, either maxima or minima, then f dash of c is 0. This is what I wanted to prove. तो मैंने क्या किया? I came from global to local. I prove. What did I prove? I prove that if your C is global, then it will be local in this case actually, because in this the point was in mid, it was not at the end point. If it was an end point, that won't be a local maxima. And I have already given you an example, that is f of x equal to x, यहीं पे कहीं पे होगा. Yeah, do you see this? This point is a global maxima, but it is not local maxima. But if you take any point in between, और in this case यहाँ पे मेरे को point क्या रहा था, in between था, I can choose a delta. I could have found out the delta, and what is my delta? This. If I got this delta, that means what? I got a delta neighborhood, and your function is less than that f of x2. Your f of x is less than f of c for all x belongs to this. That means c is local maximum. Correct? By previous theorem, f dash of c must be 0. Yeah, am I audible? Let me quickly repeat this thing. See, I wanted to do this. Actually, मुझे क्या मिला यहाँ से? Let us start. By extreme value theorem, I got that f of x1 जो रहेगा वो मेरा minimum value रहेगा, and f of x2 will be maximum. Now I have two cases. The first case is if f of x1 is same as f of x2, then what? If f of x1 is same as f of x2, that means maximum or minimum value same है, तो I can say that function is constant. If function is constant, so derivative 0. So this is the first case, that is easy, that is done. What is the next case I have to take? If f of x1 is not equal to f of x2, then what? If f of x1 is not equal to f of x2, then what? Then at least one of x1 x2 is different from a and b. Why? अगर दोनों यही रहेंगे, एंड पॉइंट ही रहेंगे, तो आई एम ऑलरेडी गिवन f of a equal to f of b. It will give me a contradiction to my assumption. My assumption I am taking f of x1 is not equal to f of x2. तो दोनों में से कोई एक तो डिफरेंट होना चाहिए. So suppose I am taking x2. Suppose x2 is different from a and b. That means what? x2 will lie between a and b. And let us take that x2 as c. Let us put c equal to x2, and I am getting a delta. Let us find a delta neighborhood. Can I first get a delta? Yes, because my point was lying in x2, and what is my delta? Delta is minimum of c minus a and b minus c. I already told you by the graph. What should I choose a delta neighborhood such that delta neighborhood should completely lie inside this, so that I wanted to make it a local maxima. I hope you agree. Since it was global maxima, I wanted to make it local maxima. So what do I have? Since this is completely lying in AB and it is already global maxima का definition क्या होता है? F of x is less than f equal to f of c, and this interval lie inside this, तो मतलब for all x in this also it is true. So what can I say now? That means c is local maximum of f. By previous theorem, f dash of c is 0. That's it. Done. Is that clear? Is the proof clear? Think about this proof again. Try to go very slow. Try to see what is happening. I'm using my previous theorem. That is, if I'm having a local maxima or local minima, then f dash of c must be 0. And I told you why this must be 0. You must see my previous lecture. Okay. What is the next? Next is LMVT, Lagrange mean value theorem. Mostly we will refer this